So I did the test and it kind of worked. I brought 3 variations to the University of Ottawa Structural Engineering Labs and it happened on Monday just as planned. So I got there in the morning and it turned out the guy, he was there, but he didn't realize I was going to test. Just a little email misunderstanding, you know? So I wasn't quite prepared. He wasn't quite prepared for what we were going to do. So he had to calibrate the machine. Once we calibrated the machines, we turned it and set it to the temperature that I was hoping to use. And that took just under like 25 minutes just for the machine to heat up to the temperature I wanted. And it sounds mundane, but I was in crazy stress, crazy suspense because when it would press, once it was at the temperature, it would show me if the concept I was designing for 2 years was going to work at all. And as it turns out, it absolutely did. The machine clamps down at probably around 12 tons of pressure, I think. And when it came out, it was a great surprise. The pellets had not only melted, but they totally fused. Like, they were totally glued together and smoothed into a full piece that fit exactly the shape of the mold they were in. And this is absolutely terrific news to me because it means, it confirms that now my full process works. I can start engineering the material to fit the machine better, but the essential process, which is that my pellets would be cut up and then have to melt and fuse together into one consolidated piece, which is how industry works and the only way this would be a competitive product. It proves that it works. The main problem to solve now is mainly the stiffness because the pieces came out consolidated and fused, but they were pretty floppy. They still felt a lot like rubber, which is not ideal, but because even the ones that had the most mineral in them still melted together, that means I can push it up higher and use stronger reinforcements. This also means that my material can be cheaper and competes better with real plastics because fillers that I use to make the material stiffer are a lot cheaper to use than the latex that they're filling, because latex is about $1 to $2 USD per kilo, and a lot of the mineral fillers I use are less than 10 cents per kilo in industrial bulk, which makes this another step of the way better to becoming a competitive alternative to plastics. I'm just so stoked overall because this means that the entire process I've been designing actually does work. Because if those plates hadn't fused, I would have crashed out, and I don't know if I would have continued this project. I haven't given up until then, but it might have been the end, so I'm so glad this worked. I'm now adapting all these formulations to have higher fillers, like I just said, and the ones that I just mixed are drying as we speak. So I'll keep you guys updated on this process of eliminating the world's plastic with a more sustainable material. Cheers.